Here's the key for the Target 9 final review. So we are doing exponential growth. The first thing you're going to do is look at the number inside the parentheses. If it is a number larger than 1, it's going to be growth. If it's a fraction or a decimal between 0 and 1, we've got decay. So for number 1, that is going to be growth. We're going to pick values for x and plug them in to find y. So this one, since nothing is being added or subtracted to the exponent, we're going to use -2, -1, 0, 1, and 2. If we plug in -2, we've got 3 to the -2 power, which is 1/9. Subtract 4 and you get -3 and 8/9. If you plug -1 in, we're going to get -3 and 2/3. For 0 we get -3, for 1 we get -1, and for 2 we get 5. So now we're going to plot those. 0, -3, 1, -1, 2, 5, -1, -3 and 2/3, -2, -3 and 8/9. We're going to have an asymptote at -4. So our domain is going to be all real numbers, and our range is going to be -4 to infinity. So number 2, if we look at the parentheses, we've got 1/2, so there's our fraction. That is going to be a decay. Once again, since there is nothing being done to the x value in the exponent, we're going to pick -2, -1, 0, 1, 2, and then we're going to do a couple extra points for 3 and 4. If we plug that in, 1/2 to the -2 power is 4, times -4 is -16. If we plug in -1, we get -8, -4, -2, -1. We'll get -1/2 and -1/4. So if we start plotting our points, we've got -1, -8, 0, -4, 1, -2, 2, -1. It's going to keep getting closer and closer to 0. So now our domain is all real numbers, and this time the range is going from -infinity up to 0. Always put the most negative number last, or I'm sorry, put the most negative number first, and then the most positive number second. This one's also decay because we've got a decimal between 0 and 1 in our parentheses. We're going to plug in -3, -2, -1, 0, and 1. We pick those because we're adding 1 to the exponent. So -3, if we plug that in, will give us -2. So if we plug in -3, -3 plus 1 is -2. 0.5 to the -2 power is 4. So if we plug in our numbers, we'll get 2, 1, 1/2, and 1/4. We'll plot those numbers, so -2, 2, -1, 1, 0, 1/2, 1, 1/4, domain, all real numbers again. Range, we're going from 0 to infinity. And the last one, the 2 in there, is greater than 1, so we're going to have growth. There's nothing being added to our exponent. If we plug -2 in, we end up getting 3 1/8. -1 gives us 3 1/4. 3 1/2. 4, 5, and if I plug 3 in there, we get 7. So -2, a little above 3, -1, 3 1/4, 0, 3 1/2. We'll have an asymptote at 3, our domain, all real numbers, and our range goes from 3 to infinity. Number 5, we're going to use one of our models. So we've got all of the formulas up here. Math department got a new photocopier. It is depreciating. So we're going to use decay. Y equals A times 1 minus R to the t power. A is our starting amount, so that's 300,000, or I'm sorry, 30,000. We want to know how much it costs after 7 years, so time is 7. The rate is 0.15, or 15%. We're going to plug that in. Y equals 30,000 times 1 minus 0.15 to the t power. I'm sorry, to the 7th power. We know our time. If we plug that into the calculator, we get approximately $9,617.31. $26 squirrels, and we know that it's growing. So we're going to use y equals a times 1 plus r to the t power. Our starting number of squirrels is 26. Our rate is 0.062, and our time is 12 years. So y equals 26 times 1 plus 0.062 to the 12th power. Calculate that out, and we get approximately 53.51 years. For number 7, we have to figure out the point, so we're going to use y equals a b to the x, and we're going to plug in our x and y values. We always want to put the larger x on top, so we're going to write two equations here. 432 equals a times b to the 4th. We're going to divide that by 2 equals a times b to the 1st. If we divide those, the a's cross out. We get 216 equals b to the 3rd power. We're subtracting these here, so b to the 4th over b to the 1st. 4 minus 1 is 3. So then take the cubed root of both sides, and we get that b equals 6. Once you get that, we're going to plug that back into y equals a times b to the x with what we know. So we're going to use the first point. 2 equals a times 6 to the 1st power. 2 equals 6a. Divide by 6. And a equals 1/3. So now that we know A and B, we're going to write our equation, y equals A times 6 to the x power. Number 8, we're looking here that the line of credit has an annual interest rate of 12.5 compounded monthly. For number 8, we are going to find out how much we will have after 2 years if we borrow $12,000 and it's compounded monthly. So compounded monthly, we're going to use compounded interest. A equals P times 1 plus R over N to the NT power. When it's compounded monthly, that's 12 times per year, so N is going to be 12. Our principal amount is $12,000. Our rate is 12.5% or 0.125. Remember to move the decimal over 2 places. And our time is 2 years. So if we plug that in, we've got A equals 12,000 times 1 plus 0.125 over 12 with a power of 12 times 2, so 12 months times 2 years. If we plug that into our calculator, we end up with $15,388.39. Number 9, we're looking at the population of Bend, which starts off at 53,000. It's growing at a 4.2 rate over a 10-year period. Since it's compounding continuously, we're going to use A equals P times E to the RT. So P is our starting amount, 53,000. R is our rate, which is 0.042. And we're looking at a time from 2000 to 2020, so our time is going to be 20 years. So we're looking for A equals 53,000 times E to the 0.042 times 20 power. If we calculate that out, we get 122,767 people. Number 10, we are buying a car and it's depreciating, so our amount is going to go down over time. That means we're going to use the decay model. Y equals A times 1 minus R to the T power. A here is our starting amount, so $26,500. Our rate is 0.12, and our time is 6 years. So Y equals 26,500 times 1 minus 0.12 to the 6th power. If we calculate that out, we get $12,306.71. Finally, you are opening up a savings plan with a deposit of $600. It's going up at a rate of 5.1% over 6 years, so we are using the growth model. Y equals A times 1 plus R to the T. Our starting amount is 600. Our rate of growth is 0.051, and our time is 6 years. So Y equals 600 times 1 plus 0.051 to the 6th power. If we calculate that out, after 6 years we have $808.66. Our last page, we're writing an equation again, so we've got x1, y1, x2, y2. We're going to plug that into y equals a times b to the x. Put the larger x value on top, so that means we've got 0.08 equals a times b squared divided by 50 equals a times b to the negative 2. The a's cancel. If we take 0.08 divided by 50, we get 1 over 625. And then b squared over b to the negative 2. Subtract your exponents and we get b to the 4th power. Solving for b, take the 4th root. That gives us b equals 1/5. Now we can plug that back into one of our equations. We're going to use the one with negative 2 and 50. So 50 equals negative 2 times 1/5 to the x power. I'm sorry, to the negative 2 power. So now that gives us 50 equals 25a divided by 25, and a equals 2. So y equals 2 times 1/5 to the x power. So comparing investments, we're looking at quarterly versus annually. So n is going to be 4, and annually n is going to be 1. So a equals 6,000 times 1 plus 0.07 over 4 to the 4 times 3 power, since we're looking at 3 years. The second one, we've got a equals 6,000, 1 plus 0.073, since we've got a 7.3% interest rate. Since n is 1, we don't have to worry about that. If you want to write that down there, it would be 1 and then 1 times 3. Calculate that out, we get $7,388.64. And for this one, we get $7,412.26. So for comparing, we want the one that has the most. The better option is B. Bacteria compounding continuously, so we're going to use A equals P times e to the RT. Our starting amount is 650. Our time is 12 hours. And our rate is 0.52. So A equals 650 times e to the 0.52 times 12. And if we calculate that out, we get 333,358 bacteria.